In the United States and much of the developed world, the average life expectancy is roughly 77 to 80 years. Yet a striking pattern appears when researchers look more closely at the data. A large proportion of deaths occur after the age of 65 from conditions strongly linked to lifestyle, cardiovascular disease, metabolic disorders, and physical frailty. But here is the important question. If modern medicine is more advanced than at any time in human history, why do so many bodies begin to fail in the decades just before 80? The answer, surprisingly, may have less to do with aging itself and more to do with a quiet evolutionary mismatch that becomes increasingly dangerous after midlife. Pause for a moment. For most of human history, reaching 60 was rare, but not impossible. Among hunter-gatherer societies studied today, individuals who survive childhood often remain physically active well into their 70s. They walk, carry, squat, and climb almost every day. And this reveals something important. The human body evolved not simply to survive, but to remain functional late into life. Your body is not failing. It is responding as it evolved to. The deeper problem is that several ordinary modern habits that feel harmless in our 40s and 50s, begin to interact with aging biology in ways that our evolutionary past never prepared us for. And after 60, those habits can quietly accelerate decline, which leads to a surprising realization. The question is not why people die before 80. The real question is why the modern environment makes healthy aging so difficult. I'm Daniel Lieberman, Harvard professor and evolutionary biologist. I've spent my career studying how the human body evolved to run, eat, think, and survive. Now I'm here to help you understand why your ancient biology struggles in a radically modern world and how to work with it instead of against it. Welcome to the evolution. If these ideas help you see your body differently, consider subscribing. Each episode explores another evolutionary puzzle shaping modern health. Let's begin with a simple evolutionary observation. Humans are unusual among mammals because we live a long time after reproduction. In evolutionary biology, this is known as a life history strategy, the pattern through which a species allocates energy across growth, reproduction, and survival. Most animals reproduce and then decline quickly. Humans are different. Among traditional hunter-gatherer populations, such as the Hadza people of East Africa, individuals who reach adulthood often remain active contributors to their community well into their 60s and 70s. Grandparents gather food, share knowledge, and help raise grandchildren. From an evolutionary perspective, older adults were not useless. They were valuable, which leads to an important realization. Natural selection did not design the human body to stop functioning at 60. It shaped us to remain capable for decades beyond that point. But capability required something very specific. Movement, not exercise, movement. Anthropologists studying hunter-gatherer societies consistently find that adults walk between 5 and 9 miles per day through routine tasks, gathering plants, carrying water, preparing food, or visiting neighboring camps. There is no gym, there is no workout routine, there is simply life. And this pattern produces something critical: continuous mechanical loading of the body. Bones experience stress, muscles remain active, metabolism stays responsive, circulation remains dynamic. In evolutionary terms, the body receives constant signals that it must maintain its structure. But here is where the modern world diverges sharply from our evolutionary past. In industrial societies, the average adult now sits for roughly 9 to 10 hours per day. Chairs at work, chairs in cars, chairs at dinner, chairs in front of screens. A pattern of stillness that would have been almost impossible for most of human history. And this creates a problem no one anticipated, because the human body interprets prolonged inactivity as a biological signal, a signal that physical capacity is no longer required, which leads to a quiet but powerful process known as biological downregulation. Muscle tissue gradually shrinks, bone density declines, metabolic flexibility weakens, cardiovascular efficiency slowly drops. These processes occur gradually through midlife, but after 60, they accelerate. And this is where the real misunderstanding begins. Many people assume aging itself is responsible for the sudden increase in frailty, metabolic disease, and loss of physical capacity after retirement age. But the deeper issue isn't what you think. Aging certainly matters. Yet much of what we interpret as aging is actually environmental feedback. Your body is constantly asking a simple evolutionary question. Is this organism still required to move? If the answer appears to be no, the body reallocates energy. Maintenance becomes less important. Strength becomes less necessary. Resilience begins to decline. This response makes evolutionary sense. Throughout most of human history, energy was scarce. Maintaining unnecessary muscle or bone tissue would have been metabolically expensive. So the body evolved to conserve resources when physical demand decreased. What feels like weakness is often ancient design. And this explains something that many people notice in their 60s. Two individuals of the same age can appear biologically decades apart. One remains capable, mobile, and energetic. The other struggles with stares, balance, and fatigue. Genetics explains part of this difference, but environment explains much more. Consider a simple example. Imagine a 68-year-old, recently retired office worker. For 40 years, most of his day involved sitting, first at a desk, then commuting home, then relaxing in a chair during the evening. After retirement, the structure of movement disappears even further. Morning routines become slower, errands become infrequent, daily walking quietly declines. Nothing dramatic happens, just a little less movement each year. But from an evolutionary perspective, something significant is occurring. The body is receiving fewer signals that strength, endurance, and structural resilience are necessary, and the body responds accordingly. But here's the surprising twist. Hunter-gatherers do not exercise more than modern people. They simply avoid long periods of inactivity, which worked beautifully for survival, but not for office life. And this leads us to the first habit that quietly becomes dangerous after 60. Not overeating, not even aging, something far more ordinary, extended sitting. And understanding why that matters requires looking deeper at a second evolutionary mismatch, one involving energy, metabolism, and the foods that now surround us everywhere. Habit 1. Extended sitting, the silent signal of decline. Let's look more closely at extended sitting, because the danger is not simply that we move less, it's that the body interprets prolonged stillness as biological information. Pause for a moment. For most of human history, the human body rarely remained motionless for hours at a time. Even during rest, people squatted, shifted posture, prepared food, repaired tools, or walked short distances through camp. Stillness existed, but prolonged immobility was rare. Modern chairs changed that, and they did so very recently in evolutionary time, which leads to a surprising realization. Sitting is not inherently harmful. The human body evolved to rest. Hunter-gatherers spend several hours each day in low-intensity activity or recovery, but their rest looks very different. They squat, they kneel, they sit on the ground and constantly adjust posture. Small muscles remain engaged, circulation continues to shift. The body remains mechanically alive. In contrast, the modern chair immobilizes the hips, spine, and legs in a fixed position for long stretches of time, and this creates a quiet cascade of physiological effects. Blood flow slows, muscle activity drops dramatically, enzymes involved in fat metabolism decrease, glucose regulation becomes less efficient. These changes can begin within hours, but the deeper issue emerges across years, because the body adapts to the signals it receives repeatedly, which leads to an evolutionary paradox. After 60, many people finally have more free time. Yet biologically, this is precisely when movement becomes more important than ever. Here's what most people miss. Aging reduces the body's sensitivity to mechanical stimulus. Muscle protein synthesis becomes less responsive. Bone tissue remodels more slowly. Metabolism becomes slightly less flexible. None of this means decline is inevitable, but it does mean the body requires clearer signals to maintain function. Your body is not failing. It is responding as it evolved to. In an environment where movement signals disappear, the body simply reallocates energy away from maintenance. And this is where the modern environment becomes misleading, because many people believe the solution is intense exercise. But evolutionary evidence suggests something different. Hunter-gatherers rarely perform high-intensity workouts. Instead, they accumulate hours of light movement throughout the day, walking, carrying, preparing food, visiting others, repairing tools, small actions, repeated frequently. From a physiological perspective, these movements maintain circulation, stimulate muscles, and preserve metabolic flexibility, and they occur naturally, which worked beautifully in ancestral environments, but not in environments organized around furniture, cars, and screens. And this leads to a culturally contrarian insight. The greatest threat to healthy aging is not the absence of workouts. It is the presence of uninterrupted stillness. A single daily walk is helpful, but it cannot fully counteract 10 hours of sitting. The body evolved for distributed movement, not isolated exercise sessions. Which brings us to a small but revealing example. Consider two individuals in their late 60s. One spends most of the day seated but goes to the gym 3 times per week for structured workouts. The other rarely visits a gym, but she walks through her neighborhood several times each day, gardens regularly, climbs stairs in her home, and runs small errands on foot. Both individuals believe they are active. Yet biologically, the second pattern more closely resembles the movement ecology of our ancestors: frequent, varied, low-intensity movement, mechanical signals delivered across the entire day. And this creates something subtle but powerful. The body continues to interpret itself as functionally necessary. Muscles remain engaged, circulation stays responsive, metabolic pathways remain flexible. This response makes evolutionary sense. Our physiology evolved in environments where daily survival required constant engagement with the physical world. Remove that engagement, and the body gradually powers down, which leads to an important reframing. Healthy aging is not primarily about pushing the body harder. It is about reminding the body that it is still needed. And this brings us to the second habit that quietly becomes dangerous after 60, a habit shaped not by chairs, but by something far more powerful: food abundance, and the ancient biological instincts that still guide how we eat. Habit 2, constant access to calorie-dense food. Now we arrive at a second evolutionary mismatch: food abundance. For most of human history, calories were unpredictable. Hunter-gatherers sometimes experienced days when food was plentiful and days when it was scarce. Seasonal fluctuations were normal. Under those conditions, natural selection favored individuals who strongly desired energy-dense foods: sweet fruits, fatty meat, honey, starchy tubers. These foods were rare but valuable sources of calories, which leads to an important evolutionary principle. Humans did not evolve to resist calorie-dense food. We evolved to seek it. This instinct helped our ancestors survive famine and environmental uncertainty. But the modern food environment has changed dramatically in just a few generations. Ultra-processed foods now combine refined carbohydrates, fats, and salt in ways that stimulate ancient reward pathways in the brain. Food companies did not invent these cravings. They simply learned how to amplify them, and this creates a mismatch no hunter-gatherer population ever faced. Food is now everywhere, available all day, engineered for maximum palatability, which leads to a subtle but important shift after midlife. As people age, their total energy expenditure often declines slightly. Muscle mass decreases gradually. Daily movement may become less frequent, but appetite signals do not necessarily decrease at the same rate, and this creates a quiet metabolic imbalance. Pause for a moment. The issue is not lack of discipline. Your instincts evolved for a different world. When the brain encounters calorie-dense food, ancient neural circuits interpret it as an opportunity that might not return soon. Eat now, store energy, prepare for uncertainty. In the ancestral environment, this response made perfect sense, but in a world of constant food access, it produces a different outcome. Small energy surpluses accumulate slowly across years. Fat tissue increases. Metabolic regulation becomes less efficient, and this creates a problem no one anticipated, because excess fat tissue is not simply passive storage. It is metabolically active. It influences inflammation, insulin signaling, and cardiovascular stress, which helps explain why metabolic diseases often appear or accelerate during the decades after 60. But the deeper issue isn't simply what people eat. It is the environment surrounding food. Hunter-gatherers do not follow diet plans. They simply live in environments where highly concentrated calories are rare. Modern environments reverse that condition, and this reveals a counterintuitive truth. Long-term metabolic health is rarely solved by extreme dieting. Instead, it improves when people gradually reshape their food environment, making nutrient-dense foods easier to choose and ultra-processed foods less constant. This is not about restriction. It is about alignment with our evolutionary design. And this brings us to a third habit that quietly undermines resilience after 60. Not movement, not food, but something even more fundamental: sleep. Habit 3. Disrupted sleep in an artificial light world. Now consider sleep. At first glance, sleep seems unrelated to evolutionary biology. It feels like a passive state, something the body simply does each night. But sleep is not passive. It is one of the most biologically active processes in the human body. During sleep, the brain reorganizes memory, regulates hormones, repairs cellular damage, and recalibrates metabolic systems. Immune activity rises, neural waste products are cleared, hormonal signals governing appetite and energy balance reset. In evolutionary terms, sleep is maintenance, and maintenance becomes increasingly important as we age. But here is where the modern environment again diverges sharply from the one in which our biology evolved. For most of human history, the daily cycle of human activity was regulated almost entirely by natural light. Sunrise signaled wakefulness, sunset signaled rest, nightfall brought darkness, real darkness. Among traditional societies without electric lighting, people typically experience 10 to 12 hours of nighttime darkness, even if they only sleep 7 to 8 hours of that period, which leads to an important insight. Human circadian rhythms evolved in an environment where darkness arrived consistently and predictably. Modern lighting disrupted that pattern almost overnight in evolutionary time. Artificial light now extends the day far beyond sunset. Screens glow late into the evening. Indoor environments remain brightly illuminated long after the sun disappears. And this creates a subtle biological confusion, because the brain's circadian clock, located in a small region called the suprachiasmatic nucleus, uses light signals to regulate sleep timing. When bright light enters the eyes at night, the brain delays the release of melatonin, a hormone that signals the body to prepare for sleep. The result is familiar to many people in midlife and beyond. Sleep becomes shorter, more fragmented, less restorative, and this creates a cascade of downstream effects. Pause for a moment. Sleep disruption alters hunger hormones, increasing levels of ghrelin while reducing leptin sensitivity. Appetite rises, especially for calorie-dense foods. Cognitive function becomes less sharp. Mood regulation becomes more difficult. Inflammatory signals increase, which leads to a surprising realization. Sleep disruption amplifies many of the other evolutionary mismatches we've already discussed. Reduced sleep encourages overeating. Fatigue reduces physical activity. Metabolic regulation becomes less stable. The body enters a feedback loop, and this loop often intensifies after 60. But your body is not malfunctioning. It is responding to environmental signals. For most of human history, night meant darkness, quiet, and a gradual slowing of activity. Today, night often resembles a second daytime. Artificial light, endless information, constant stimulation. From an evolutionary perspective, the brain struggles to interpret these signals. This response makes evolutionary sense. Our biology simply has not had time to adapt. And this leads to a culturally contrarian idea. Improving sleep is often less about forcing the body to sleep longer and more about restoring environmental cues that tell the brain when night has truly begun. Darkness, reduced stimulation, consistent timing, small changes that realign ancient circadian systems with modern life. Because when sleep stabilizes, the body restores one of its most powerful tools for maintaining resilience through the later decades of life. But there is still another habit quietly accelerating decline after 60, and it may be the most overlooked of all: chronic stress without physical release. Habit. 4. Chronic stress without physical release. Now consider stress. Stress itself is not a modern invention. Humans evolved powerful stress responses because they were essential for survival. When our ancestors faced danger, a predator, a rival group, a sudden environmental threat, the body activated a coordinated physiological response. Heart rate increased, breathing accelerated. Stress hormones such as cortisol and adrenaline surged through the bloodstream. Energy was mobilized, attention sharpened, the body prepared for action. Fight, run, climb, defend. But here's the key point. In ancestral environments, stress was usually short-lived and physically resolved. A threat appeared, the body reacted, movement followed. And once the event passed, the nervous system returned to baseline, which leads to a surprising realization. The human stress response evolved for acute physical challenges, not for continuous psychological pressure. Pause for a moment. Modern life rarely involves predators or immediate survival threats, yet many people experience chronic stress in different forms: financial concerns, work demands, caregiving responsibilities, social pressures, and the constant flow of digital information. The body cannot easily distinguish between these modern stressors and the ancestral threats it evolved to manage. Cortisol rises, heart rate increases, muscles subtly tense. But unlike our ancestors, many people remain physically still while this stress unfolds, sitting at a desk, driving in traffic, lying awake at night. And this creates a biological mismatch because the stress response prepares the body for movement. Without movement, those physiological signals linger longer than they were designed to. Over time, chronic elevation of stress hormones can influence blood pressure, immune balance, metabolic regulation, and sleep quality. These effects accumulate gradually through midlife, but after 60, resilience to prolonged stress often declines slightly. which means the same stress load can have a stronger physiological impact. But your body is not weak. It is responding exactly as it evolved to. In ancestral life, stress almost always involved physical action. Running, climbing, carrying, or defending required muscular engagement that helped metabolize stress hormones and reset the nervous system. Modern stress often removes that outlet, and this leads to a culturally overlooked insight. Movement is not only important for muscles and metabolism, it also plays a role in regulating stress physiology. Walking, gardening, light physical work, even gentle daily movement can help restore the natural cycle between stress activation and recovery. Because the body evolved expecting that cycle. Without it, stress becomes something the body carries rather than something it resolves. And that accumulation quietly shapes health across the decades after 60. But there is one final habit that may influence aging more than most people realize. Not food, not movement, not even sleep. Something deeper, purpose. Habit 5. Loss of purpose and the biology of contribution. The final habit is less physical, but no less biological. Purpose. At first glance, purpose may sound like a psychological concept, something related to motivation, identity, or personal fulfillment. But from an evolutionary perspective, purpose has deep biological roots. Humans evolved as intensely social organisms. Survival rarely depended on individuals acting alone. Instead, people lived in small, cooperative groups where each member contributed in different ways. Some gathered food, some hunted, some cared for children, others shared knowledge, repaired tools, or resolved conflicts. Contribution was not optional. It was embedded in daily life. And this created something subtle but powerful. Every individual, including older adults, had a functional role within the group. Among the Hadza people and many other traditional societies studied by anthropologists, older adults remain deeply integrated into community life. They gather foods that require experience to locate, process plant materials, provide childcare, and transmit cultural knowledge. Their role changes, but it does not disappear, which leads to a surprising realization. Human longevity may have evolved partly because older adults increase the survival of younger generations. Anthropologists sometimes call this the grandmother hypothesis, the idea that post-reproductive adults helped sustain families and communities. In evolutionary terms, contribution supported survival. And the human brain appears deeply tuned to this pattern. Pause for a moment. Modern societies often organize life differently. Many people spend decades working in structured roles, careers that provide daily responsibility, routine, and social interaction. Then retirement arrives. Suddenly, the external structure disappears. The alarm clock stops. The schedule dissolves. Responsibilities shrink. For some individuals, this transition brings welcome freedom. For others, it introduces something more complicated, a quiet loss of role. And this creates a biological ripple effect that researchers are only beginning to understand. Purpose influences behavior. People who feel socially useful tend to remain more physically active. They maintain routines. They interact with others. Cognitive engagement remains higher. In contrast, when daily structure disappears, activity patterns often decline. Movement decreases. Social contact narrows. Cognitive stimulation becomes less frequent. And these changes can quietly influence both physical and mental resilience. But the deeper issue isn't retirement itself. It is the sudden removal of contribution from daily life. Your body and brain evolved expecting continued participation in a social system. When that expectation disappears, the signals that sustain engagement begin to fade. This response makes evolutionary sense. For most of human history, older adults rarely withdrew from community life. They shifted roles. Teacher instead of hunter, caretaker instead of gatherer, advisor instead of explorer. But they remained needed, which leads to a powerful reframing. Healthy aging is not only about preserving the body, it is also about preserving participation, small responsibilities, regular social interaction, activities that allow experience to benefit others. These signals tell the brain something important. You still matter. And when the brain receives that signal, behavior often follows. Movement increases, routines stabilize, and cognitive engagement remains active. Because the human organism evolved not just to survive individually, but to contribute collectively across a long life. And this brings us back to the question we asked at the beginning. If humans evolved to remain functional into older age, why do so many bodies begin to fail before 80? The answer, as we've seen, is not simply aging, it is the modern environment. Let's return to the question we began with. If modern medicine is more advanced than at any time in human history, why do so many people begin to decline before 80? The answer is not simply aging, it is environment. Human beings evolved in conditions that continuously reinforced physical capability. Daily life required movement, food was intermittent and unprocessed, nights were dark, stress was physical and temporary. Older adults remained embedded in social roles that demanded participation. Those conditions quietly maintained the systems that support long life: muscle, metabolism, sleep regulation, cognitive engagement, social connection. Remove those signals, and the body begins to adjust. Pause for a moment. Your body is not designed to maintain strength, metabolic stability, and resilience automatically. It maintains those systems only when the environment repeatedly signals that they are necessary. This is one of the most important insights evolutionary biology offers about aging. Longevity is not simply programmed into the body, it is continuously negotiated with the environment. And this leads to a realization that many people find both surprising and reassuring. Your body is not failing, it is responding exactly as it evolved to. When movement declines, when calorie-dense foods become constant, when artificial light disrupts sleep, when stress accumulates without release, and when meaningful participation fades, the body interprets those conditions as signals that long-term maintenance is less essential. Energy is conserved, repair slows, resilience gradually decreases. But the reverse is also true. When the body receives signals that movement is required, that sleep cycles are stable, that food is balanced, that stress resolves through activity, and that participation continues, many biological systems remain remarkably adaptable, even later in life. This response makes evolutionary sense. After all, our ancestors who reached older ages were rarely idle observers of life. They remained engaged with the physical and social world around them, and that engagement helped sustain their capability. Which brings us to a simple but powerful idea. Healthy aging is not about fighting biology. It is about working with the ancient signals that biology understands. Small environmental shifts, repeated daily, signals that the body still matters. Because the human organism did not evolve merely to survive into old age, it evolved to remain useful there. And in our next exploration, we'll look more closely at another evolutionary puzzle: why the human body often resists exercise, even though movement is one of the most powerful signals for maintaining long-term health.